Okay, shall we start? Am I audible, guys?
Yes, sir.
Okay.
Yes, sir.
Okay. So we'll start today. Okay. So we were discussing. Okay, since many are did not attend the first few classes, so I would just give the hint of whatever we have covered in the first two classes. Okay. So first one we have discussed about the IP, which is known as the indicated power. We have started the module number 1. And that second part, which is IC engines. So first we will cover IC engines for the internal number 1. So IP we have discussed, which is known as the indicated power. Okay, just a minute. Okay, so IP is nothing but what? IP is indicated power. Okay, what is this indicated power? This is the power which is developed within the engine. Suppose this particular engine is like this. Okay, so whatever the power which is developed inside the engine is known as the indicated power. So how will you calculate this indicated power then? So this particular indicated power is calculated by formula IP is equals to PLAN divided by 60. Okay, and this particular formula is for the two-stroke engine. Kindly note all these points. This is for the two-stroke engine. Suppose if it want for the four-stroke engine, the same formula can be modified as this much, plan divided by 60 cross 2, and this becomes the formula for the four-stroke engine. Okay, this becomes the formula for the four-stroke engine. So for the two-stroke, there is nothing to be divided, but when it comes for the four-stroke, you have to divide it by 2. Keep this in mind. Okay, so this is about the indicated power. And this particular indicated power is for the one simple cylinder like this. Okay, suppose there are many cylinders, say 4 cylinders are there. So what you have to do is, when you want to calculate IP for the whole thing, you have to take it as plan divided by 60 into, so how many cylinders are there? 1, 2, 3 and 4. So it is multiplied by 4. So this gives you the overall indicated power of all the 4 cylinders. So we shall discuss about this in the problems in a detailed fashion. So now we will discuss what are the different parameters are involved. So P is there. So P you can just add a suffix to it, which is yum. So P to the suffix yum. So what do you mean by PM then? PM is nothing but the mean effective pressure. What do you mean by PM? PM is the mean effective pressure. So how do you calculate this mean effective pressure? So one thing he would be directly giving in the problems, in the problem statement. If he has not given it, then he would be giving you the indicator diagram. Okay, so he would be giving you the indicator diagram. So what is this indicator diagram? It is something like this. So a diagram would be plotted using some machine, and that particular machine requires a spring like this. Okay, so S is the spring constant of this particular spring, which is used to draw this particular indicator diagram, and A is the area of this indicator diagram, and L is the length of the indicator diagram. Okay, so all these things are there. From this, you can find out what is the value of the PM. So PM is equals to, simply it is SA by L. Okay, so this is a formula through which you can calculate the mean effective pressure. So what is S? You can write it here if you want. S is nothing but the spring constant. S is nothing but the spring constant. A is nothing but the area of indicator diagram. Okay, and L is nothing but length of the indicator diagram. L is nothing but the length of the indicator diagram. So this is how you have calculating the value of PM. So PM is done. So what are the remaining parameters there? The remaining parameters are L. Okay. So L is nothing but what? It is just the length of the stroke. Length of the stroke is nothing but the distance through which the piston moves. The piston moves through a certain distance, isn't it? That particular length is length of the stroke. And next you have A there. Okay. What is A? It is nothing but area of cross section of cylinder. Area of cross section of cylinder. So how would you understand this particular thing here? So there will be a cylinder, there will be a piston. Generally, this would be of a circuit. So how do you calculate the area of this particular thing? Suppose if this is the diameter, okay, so this is the diameter. So how would you calculate the area of the cylinder? Yes, and
ID square by 4.
so it is pi d square by 4, where d is nothing but what? D is the diameter of cylinder, so which is also known as the bore. D is diameter of the engine cylinder, which is also known as a bore. So now A is done. What else is remaining in this particular formula? So PM is done, L is done, A is done, and N is done. N is not done, right? So N is what? Any guess? What do you mean by N there?
Number of loop.
Any guess?
RPM.
Yes?
RPM.
RPM, isn't it? So N is nothing but RPM. It is engine speed, I can say. So engine speed is in RPM. So this is how you calculate the various parameters which are required for the calculation of IP. Now let us go for BP. Okay. Next one is the brake power. So how do you calculate the brake power? So first of all, what do you mean by brake power? Let us see. So there is an engine cylinder, and there is a piston like this, and this particular thing drives a crank. Okay, this crank will rotate all the way like this, and this particular thing is connected to a shaft, and this shaft would rotate like this, correct? This is how the engine operates, am I right?
Yes, sir.
So the power which is developed inside an engine is known as what? We have discussed just now. What is that? The power which is developed
Indicated
inside
power.
the engine. Very good.
Indicated
So it
power.
is indicated power. Now, the power which is available at the crankshaft. So this is the crankshaft, isn't it? So the power which is available at this particular crankshaft is known as the brake power. Getting my point? So what is brake power? Brake power is the power which is available at the crankshaft. So how do you calculate it? For that, you have a certain arrangement. Okay. Now, what I would do is, I would just place this particular shaft here like this. So I would take this shaft. Okay. For this shaft, what I would do, I would attach a pulley. On this pulley, I would add a rope like this with certain amount of thickness. Okay, so I have attached a rope. So, and then I would attach weights onto this. Now I am attaching the weight. Okay. So now carefully observe this. So this is known as brake drum dynamometer. So the diameter of this particular brake drum, let it be capital D. Okay. And the diameter of this particular rope, let it be small d. Okay, let it be small d. And weight, of course, the W is the weight of whatever we have added. So in order to balance the C, this should not wobble like this, isn't it? It should not wobble on both the sides. In order to do that, we'll be having a certain spring balance arrangement on both the sides. Something like this, I could say. Okay. There would be a spring balance arrangement. Okay, that would be attached here. So the spring balance reading is yes. Okay, so this is the arrangement to carry out the take out the brake power. So first of all, what is the formula to calculate the brake power? So it's simple. So brake power is equals to 2 pi nt divided by 60. So again, where n is engine speed, so this should be an RPM. Engine speed would be an RPM. Now you need to calculate the torque. For torque calculation, you have a formula W minus S into capital D plus small d divided by 2. So you have to remember this particular formula to calculate the torque. So what is meant by W here, N1? So W is
Wait,
nothing but, can I say it's as a weight on the brake drum? Correct? So I would write here it as the weight on brake drum. Next parameter is S. S is nothing but the spring constant, correct?
Yes, sir.
Next capital D, yes. What do you mean by capital D then?
Diameter of the wheel. Drum.
Diameter of drum. So it's a diameter of the brake drum. Next, small d.
Diameter of rope.
diameter of rope.
It's the diameter of the rope. So with these all parameters, I can calculate my torque and I can calculate the brake power by substituting the torque, which is calculated here. So this is how you calculate the brake power. So got the difference between the indicated power and the brake power? So what is indicated power and what is brake power and what is the difference between these two? Anyone? What do you mean by indicated power and what do you mean by power?
What, sir? In indicated power, energy is developed inside the engine.
Very good. What about brake power?
Energy is available in
Crankshaft. So the energy which is available at the crankshaft is known as the brake power. So this is all about how you calculate the indicated power and the brake power. Now let us see, there is something known as frictional power. What is meant by FP? It is frictional power. So what do you mean by this frictional power? So it is simply FP is equal to IP minus of BP. Correct? So it is L minus of BP. Between these two is friction. Next is mechanical efficiency. Fourth part is mechanical heat mechanical is nothing but brake divided by indicated power. So yeah, power. I guess any problem in the net, guys?
Any problem in the network?
No, sir.
So mechanical efficiency is done. Next, we'll go for volumetric efficiency. So for offline classes, I have given a better example for them. So fifth one is the volumetric efficiency. Okay, volumetric efficiency, eta volume. It is denoted as eta volume. So, how many of you have the bikes which has got more than 150 cc? More than 150 cc bikes. No one? Bike? No. Audible? Cubic centimeters. So this is a bike like this. Its cylinder capacity is 500 cc. Do you think all 500 cc would be occupied?
Darshan, Sir, not able to this, sir. Your voice is breaking.
सर इज्जी मारे हैं
భలే భలే
నా కుడెన్స్ అకౌంట్ ఉండారన్న
Nishan Pura, college పోతేనా మరి college.
ए चिराग you college में थे ना yesterday
yesterday I had been to college.
Chirant monthly class.
निकले री रे मल प्ले रे सर लगा कुछ और
I guess there's a network problem, right? Now it's clear.
Yes sir.
Good. So if there is a 500cc bike, then definitely the whole lot of 500cc will not be occupied by the gas, incoming gas. So there will be a difference, isn't it? So that's why there is a concept of volumetric efficiency. So volumetric efficiency is nothing but it is a ratio of actual air which is getting in the cylinder and divided by cylinder volume. So actual air is which is getting in during the suction stroke, that parameter divided by overall cylinder volume. That gives you the volumetric efficiency. Now coming to indicated thermal efficiency. So indicated thermal efficiency is simple. So it is indicated by eta indicated thermal like this. So indicated thermal is equal to IP divided by MF dot into CV. So it is a ratio of indicated power to the energy produced by the fuel. So you can just note it down here. So MF dot is nothing but what? MF dot is the mass flow rate of fuel, mass flow rate, mass flow rate of fuel, and CV is calorific value of fuel. So mass flow rate of fuel is in kgs per second and calorific value is in joules per kg. So note it down these two units also. Similarly, you have brake thermal efficiency. Brake thermal efficiency. So what do you mean by this brake thermal efficiency in the sense? Any guess? Any guess?
BP, sir. BP divided.
Correct. So it would be brake power
BP divided by
by MF dot into CV. So again, MF dot is nothing but mass flow rate of the fuel and CV is calorific value of the fuel. Next is the specific fuel consumption. Okay. The eighth one is specific fuel consumption. So what do you mean by this specific fuel consumption? In the sense, it is the fuel consumed per unit time per unit power output. So that is known as specific fuel consumption. Again, it has two types in it. One is indicated specific fuel consumption, which is nothing but MF divided by IP, which has the unit kg divided by kilowatt hour. Same thing again. Brake specific fuel consumption, which is MF dot divided by BP lab. The units remain same, kg divided by kilowatt hour. Okay, so this is all about. And again, switch off your mic. So these all things you have to know about different parameters of the things. Okay. Anyhow, I will be giving you the notes, so a soft copy of this to update in your notes. So have a habit of writing the notes. In the next class, we will be solving some of the problems on IC engines. Okay, so make sure everyone have the calculators with you. Within next class, you have to bring your notes, write the COs which I have sent you in the group. Okay, and complete the notes up till today's class. I will give you the soft copy in the Google Classroom. From there, you can pick up and write your notes. Okay. After that, write whatever been taught in the BTD. I have told you, all the 5 processes with the workflows and heat flows in the last page of your notes. That would be very easy for understanding ATD. Okay. So with that note, we would end up today's class. Any doubts in today's class, you can ask now, or else we will end up this.
No, sir.
Okay.
Thank you, sir.
We will,
Sir, they are not leaving from hostel, sir.
They are not leaving you from the hostel.
Yes, sir. They are not leaving
Sunnadi,
for.
bro.
Just a minute, I will just stop the recording.